Okay, so we're going to pull ourselves away from the player. We were right in the last video. We were going to be taking a look at the projectile. So starting out, in this video, all we're going to do is get our game object set up. We're going to get the script started, and the script is going to have the code in it just to make it move up the screen and to make sure that it is destroyed once it gets off the screen.
Okay.
Because there's no reason for that object to continue living.
But it won't be firing from the position of the player.
No, it will not be firing from the position of the player yet. Okay, so that is our goal. So let's go ahead and get started. First thing that I'd like to do is to create my game object. In this case, what we're going to do is create a capsule to use. So we'll come back up here to game object, come down to create other, and then from there, just jump down to capsule. Now, from the capsule, first thing I want to do over here in the inspector is set a name. So, projectile.
You should leave it just like that. We have a block that shoots Tylenols at the enemy.
That's what it looks like. So we've got projectile in there. Position 000 is great. Scale, well, like you said, it's a giant Tylenol. Let's go ahead and bring this guy down in size to something like 0.2. So I'm just going to jump across real quick. Now we have a laser.
Okay.
0.2. Now we have a teeny little guy, and I'll go ahead and keep things consistent with Z as well.
Oh, it's a little Tylenol.
So now we have a little bitty guy. The next thing I'd like to do is to create a material to apply to this game object. So again,
as long as it's not half red and half white.
Over here in the materials folder, I'll just right click on it, create, and then come down once again to material. And then let's give a name. So we'll simply click, do M underscore and projectile, like such. And let's go ahead and set our main color. For now, let's just do green.
Okay.
So, oh, I don't like that green. There we go. That's nice and bright. So we've got green, and all we need is to make sure that this guy gets applied. So, as we've seen before, we could simply click, drag, and drop him up here on projectile, or we can just activate projectile and then come over here and grab our M projectile and just come over here and replace our guy. There he is, green. So the default diffuse, bye-bye. New guy is now in play.
And now our player is obviously a bad guy because the bad guys shoot the green lasers.
Do they now?
They do. You saw Star Wars.
They're not purple? Oh, yeah, good point. I'm thinking lightsabers. So moving right along. You saw nothing. Okay, so we've got a material set. Now it is time to apply a rigid body. Collisions are going to be a very important thing in this game, and they are in most games, most action games anyways. So when this projectile collides with an enemy, we would like for the enemy to, well, you know, explode. That's kind of good.
Yeah,
but we need for the collision to occur, and somehow we need to have a section of code get triggered when we have that collision between a projectile and an enemy. Okay, so in order to take advantage of is trigger, which happens to be on a collider, there's a few things that we're going to need. We're going to need rigid body on at least one of the objects that are involved. We're going to need colliders on each of the objects that are involved. And we're going to need one of these guys to be set to is trigger, maybe both if you want to get called in both objects about the collision.
Sure.
And we're going to focus on this a lot more when we get into the collisions later, excuse me. But right now, what I'm wanting to do is just kind of point out why I am about to add a rigid body. It's just a requirement, having at least one when we're wanting two objects to collide in the sense that we're going to be using the is trigger. Now, let me stop right there because you're still giving me a confused look.
No,
that's great.
You're good. You're good. But go ahead.
We can take advantage of the physics body, or excuse me, the physics engine here with Unity. We can have two things collide and bounce off of one another, etc. We can also take advantage of this system to call a function for us, one that we can override, that lets us know we just collided with somebody.
A collision event, if you will.
Kind of like a collision event. And we can also tell the physics system not to manipulate our geometry because of the collision. Let us do it in code.
Okay.
To do this, what I need to do is add a component to my projectile. So the component I'm going to add to this game object is going to be a rigid body because I need to have at least one rigid body involved in a collision. So what I'm going to do is come up to component, come down to physics, and then from over here I'll simply select rigid body. With my projectile selected, you'll see that a rigid body has now been added to my game object.
Gotcha. So that's just giving us access to collisions.
So yes, this is really going to facilitate the trigger working properly.
I gotcha.
And what I mean by trigger is we are taking advantage of the isTrigger property over here on the collider. So when we create an enemy, he's going to have a collider on him. He's not going to have a rigid body. We've created this guy. He had a collider by default. And even our player has a collider on him by default. But what they didn't have was a rigid body. For two things to be able to collide and for us to get that callback, at least one has to have a rigid body.
So in this case, the projectile is kind of the catalyst.
So that's right. So he's got the rigid body on him. Okay. So the next thing that I want to do is come over here to the rigid body and say use gravity. No.
Yeah, because you say rigid body, and just because I come from the 3D background, I immediately think of stuff falling and bouncing on the floor.
Gotcha. And we can very easily pull that off with Unity.
Gotcha.
And that's not what we're looking for right now. So we're not going to use gravity. The next thing that we're going to do is we're going to check is kinematic. This is very important. The reason we're checking is kinematic is because we want to make sure that our script is able to influence this guy.
Yeah.
Okay. We don't want for the we don't want for the physics engine to calculate any sort of interaction between two colliding objects.
We want to tell it where to go, not let it be simulated.
Exactly. Okay, so we won't control, so we're simply just going to check that to make sure that there is no external force calculations or anything that's going to be calculated by the physics engine. So now that's not going to happen. And that's pretty much all I wanted to set up there. And now the next thing we need to do is move on to the script. And again, if any of you out there watching feel a little confused about the collision stuff, don't worry. All we've done is added a rigid body. Soon we're going to come back in when we actually have an enemy to collide with, and I'm going to make everything clear. I'm going to point everything out once again and talk about what is required to make this happen. Now, let's get a script down here. So for the script, what I'm going to do is simply, I could add a new script here, or I can come over here. Now, this is cheating. This is awful. I've already created a template that I can use.
Cheater.
So, okay, I won't cheat then. But I'm going to show you guys how to create a template later so you can do exactly what I'm doing right here.
Cheaters never prosper.
So let's come over to scripts. Thanks, Zach. You're keeping me in line. So on scripts, I'm going to right-click, and we're going to create a new, once again, C# script.
Did you lose your material, or am I going colorblind?
Oh, we sure did. We need to set that color again.
Okay.
Let's go ahead and set this guy to a projectile, the name. Okay. So we've got projectile in there. Let's come back up here real quick to our projectile and come down to our material and set that color back to nice and
Imperial laser green.
Yeah, there we go. Almost. Not feeling Star Wars enough yet. Oh, I am now. Okay. So we've got the color set. So we've got this guy. Let's come over here real quick and take a look at Visual Studio. It's noticed that there has been a modification outside of the environment. And do we want to reload? And I'm just going to tell it to go ahead and reload. One, you're going to see that the projectile.cs file now shows up here in our solution. Number two, here we are talking about the inconsistent line endings. Remember I said earlier that that's a warning that we saw because of the way that the file is created when you do it inside of Unity versus the way it's done when you create a new script inside of Visual Studio, Windows-based file creation. You'll notice right here that this is talking about the player CS file. So I'm just going to tell it, yeah, let's go ahead and fix stuff. Everything's happy. Now, we've got our projectile over here. I also have an asterisk up here on our player, so let's go ahead and save that guy out. Come over to our projectile, so I'll double-click it. Now, what do we want to do here? First thing, do you remember?
We need to set a position.
Position? Even before that.
Even before that. Oh, we need to change our name.
You got it. We need to make sure that our class name matches the actual file name.
And to go back through all the things we did.
All right. It's amazing we're still going, and here it is, very late in the morning. Okay, so projectile, inheriting from mono behavior. We have a start and update being provided by the template. We can go ahead and jump back over here real quick. Let's make sure we save that, though, because, again, you can see it's not been saved. So we'll save it. We'll jump back over. No warnings. Notice how everything's been cleaned up, which is real nice in regards to that end of line character. So let's go ahead and take projectile, drag and drop it up here on projectile. So when you click on projectile, you can see that we now have the projectile script added as a component. Now let's jump back down. Next thing I'm going to be interested in doing is setting up a projectile speed data member, because I'm not sure what kind of speed I want at the moment. So again, I'm going to make this public. If I make it private, it's not going to show up over in the inspector.
Okay, that makes sense.
Just make him public, and then let's give this guy a data type of float and call him projectile speed. And we'll go ahead and save this guy out. So once again, as soon as I select back over here, compiles, and you can see projectile speed gets added in.
Actually watched it pop in.
I have no idea what kind of speed I want. Let's maybe start out with 10, but that's a nice thing. We can adjust this. So let's go ahead, coming back over here. So now that we just saved out our projectile file, this is one will need to be cleaned up later by Visual Studio, because you can see the inconsistent ending. But I'm pointing it out.
Yeah.
Don't worry about it. All right. Just in case anyone's watching going, but you got a warning. All right. So now that we have speed, let's get this guy moving, but the direction he wants to move is up. So we're going to be moving up in the Y axis.
Positive Y.
So we're moving up in positive Y, as you can see over here. So all we need to do is, well, the exact same thing that we did over in the player script, and that is come in here, figure up an amount to move, and then simply translate the guy up instead of left and right.
Okay.
So simple enough. Again, we're just going to do a local variable inside of update, which is going to get called every single frame, and we'll call it the same thing, amount to move. And we'll say that amount to move is equal to projectile speed times, and we better put this in because we know we're going to need it, time dot delta time.
Yeah, notice this time we're not taking in any inputs from the player.
Nah, we don't need to.
Because this is going to be propelled on its own. It's not like it's not like you're actually using the joystick to move your laser around.
That'd be cool.
That'd be a cool weapon, though.
Yes, it would. So now we've got that in. All we need to do is call on transform on the function translate. And what do we want to translate? Now, of course, we could again apply a new vector 3, or we could just use one that has already been set up for us, which is in this case vector 3 dot up. And we can take dot up and multiply that by amount to move.
Which in this case will always be positive.
Which is going to always be positive. You are absolutely right. So with that, let's hit save. Now this right here, since we've already got our script applied to our projectile, the moment we hit play, this is going to kick into action.
It's just going to fly away.
So it's just going to fly away. So let's come back over here and check it out. Hit play.
Goodbye.
Hey, we got a projectile that's moving.
Yeah.
But the problem we have, as I position our scene to watch, is we have a projectile that moves and moves
and never goes away.
And he never goes away.
Now that means it's still going to be calculated by the engine, even though we don't see it.
He's still being calculated. Not good.
Yeah.
So what if we were to first focus up on him? Let's back away a little bit. What if we were to destroy him the moment he went off screen?
Another if statement?
So, yeah, sounds good to me. So let's just, again, we're taking the black and white approach, keeping everything simple. So instead of using any type of special formula for calculating the top of the screen, let's just simply drag this guy up and see what we consider the top of the screen. So back out a little bit.
Something like a couple of pixels beyond the visible range.
You got it. So looking over here, so there we go, kind of sliding off about right there. So we can say 6.4 looks good to me.
Sure.
So if he's at 6.4 or greater,
destroy him.
Yeah, we want to destroy him. So just move this guy on back down, just so I have some room for him to move up. Jump back over here. And as you said, we're going to do an if statement. So we're going to say if. Now, again, we are the script. We are attached to the game object. We want to refer to a component on that game object, transform. Now, I haven't said this before, but this is something that you're going to see me using a lot. You notice how I've been just starting out by typing transform like such? I could have started out by doing this, game object. So now what we're doing is we're saying this being the script, the projectile script, that is actually attached to the game object. Okay, so us, game object, that's the guy we're attached to. Then I could work my way back down. Let's go to transform and then go on from there. And this code would work beautifully.
Right.
But since there is no other transform component available anywhere, I can simply just say transform.
I gotcha.
Very helpful. I just wanted to point that out because we will have to refer to game object from time to time. But game object will immediately tell us, hey, this is the guy we're attached to.
Right.
We didn't do it. It's him. So here we are, transform. So now, what do we want to do? If transforms position dot, well, which way are we checking? Y. And we said if he's greater than, not question mark, greater than or equal to, I'll just say greater than. What did we say? Remember the number?
6.4.
6.4, absolutely. So 6.4, throw an F in there to indicate we're talking about a float. So if it's greater than 6.4, then what do we want to do? We want to destroy it. And destroy is functionality that's built into the Unity engine that since we have Unity engine as something that we're using here, we can just type it out. So let's try it. Destroy.
And it'll automatically know that it's this thing we're destroying as opposed to destroying something like the player.
Well, destroy wants to know the game object.
Okay.
So watch this. So destroy, and I'm going to say, well, there's a ton of ways to say it. I'm just going to say game object.
Okay. So can you say this?
Very good. Let's put that in there just because you said it. This dot game object. So it's me saying, hey, the script, us, our game object that we're attached to. So that's how you can read that.
Whatever this thing is that just went over 6.4.
So yeah, this being the projectile script dot the game object that we are attached to. So now if we were to go above 6.4, we're going to destroy ourselves. So let's save that. Let's come back over here. Let's position ourselves where hopefully we can see, and hit play. And
boom,
look at that.
Disappears.
He's gone, completely gone. And that's it. It's as simple as that. Now let's jump back over here, and again, just for educational purposes, let's go ahead and just bring this down to game object only, and save, play, and up, and boom. He's
Still
gone.
works just fine.
Still works just fine. And the other thing I wanted to demonstrate was, let's go ahead and say game object here, just to back up what I was saying about this allows me to gain access to the game object we are attached to. Save, play, boom.
Now, it doesn't matter in any way which ones of those you use, or is there any efficiency concerns as to how you write that out?
Well, that's a very good question. Yes, there are, especially if you're coding for the iPhone. Right now, every time that we're looking at transform here, we're having to do a lookup to get this guy. There's a little bit of processing involved there. One of the things I do, especially when you're writing something for the iPhone and your processing power is so precious, every cycle means so much to you, is I will do the following. I can come up here and say I'm going to keep a private transform, and we're going to call this, I'll just call it my transform.
Sure. I already see where you're going.
Then in start, I would say my transform equals transform. Now, if I do this, now remember, start's going to get fired one time, right before the very first update's called. So we know that this will be good. We're guaranteed that. Now I can come down here and watch this. If instead of transform.translate, let's just kind of push this over to make my point. If I say my transform dot, it has everything available, including translate. And if I was to then come in here and just update that like such, nice and happy. Again, same thing right here. Instead of doing the lookup to the actual component, instead I say my transform dot position, then this right here is actually, we're holding a reference already. So the moment this thing gets fired, moment start is hit, we do one lookup.
One store, store a value just once, right?
Yep. We find where that object is out in memory, and we hold a reference pointing straight to him. Now, every single time, 5,000 times a second or whatever it may be that we're hitting update, we're not having to look out into memory and look him up every time.
Right.
We know where he's at. So this right here, so what you said, you didn't realize what you were stumbling on. You actually said a really important thing if you're doing iPhone development.
Gotcha.
How important is this when you're doing development for, say, the PC or for the web? Nowhere near as important as working with the iPhone. But this is still an optimization that I would suggest doing.
So it's one of those things where, like, if you're doing it for a PC or for the web, you don't necessarily have to do it, but it's still a good idea.
It's still a good idea. It's still an optimization.
Yeah, and it's not like it's any less valid.
It's just you've just made the computer do less work.
Right, to do the same job.
Every single frame. Yeah, because you're now holding a reference pointing right to the guy.
Gotcha.
It's like if I wanted to go to a friend's house and I didn't know where he lived, so I have to go through the trouble of looking him up in a phone book and then MapQuest to get the directions out and then go there.
You still use MapQuest.
Or whatever. It's the first thing that came to mind. Google Maps.
There you go.
Yeah, I know what you're getting at. But every single time, let's say that I went to his house 1,000 times a day.
Yeah.
I went through looking him up every time.
Right.
Oh, wow, what a waste of resources. So anyways, with this in place, let's go ahead and save, come back over here and check and make sure our functionality is the same. Hit play, he goes up, and he vanished.
If you go to a friend's house that many times in a day, the cops are getting involved. You know that.
Yeah, probably so. Actually, that's a fact. So anyways, there you go. That is a quick demonstration of caching out our transform, our component. Now, is there anything else that I want for us to do in this video? I don't think so. I think we've accomplished what we set out to do.
And a little more.
And definitely more. The goal was simply to create a projectile, create a material, apply to the projectile, give it some sort of color. From there, and again, we're just keeping everything standard, default. From there, we wanted to make sure that a rigid body had been applied as a component to our projectile game object, because this is going to become very important in triggering that collision. And then from there, we wanted to go ahead and create the script, apply the script, and have the script do nothing more than make him move up the screen. But the key thing was make sure that he was destroyed if he moved off the screen.
Right.
Okay. So with that is going to wrap this video up. And in the next video, we're going to talk about prefabs for a minute. Thanks a lot, guys.